Alright, so for number 6, that one is a candidate for synthetic division because we're dividing by b minus 4. Okay, so I put the 4 inside the little backwards L. And notice that there's a placeholder here because there is no, there is no square term. So this is the fourth power, the third power coefficient, the squared, the b, and the constant. Okay, so now just like before, we bring down the 8. Multiply 8 times 4 is 32. And then you add, you get 30. 30 times 4 is 120. You add, you get 120. 120 times 4 is 480. 480 plus 1 is 481. And then 481 times 4 is 1924, 1924. And then minus 4 is 1920. Okay, so this is the remainder. So when you write the answer, you're going to say, let's see, I'm going to write it in standard form, so it's going to be 8b to the fourth minus 2b cubed plus b minus 4. So the dividend equals the quotient, the divisor times the quotient squared plus 120. I'm taking the numbers from here, okay, as those are the coefficients of the quotient. 120b plus 481 plus the remainder. And so here's the answer. Alright, number 7, I think there was a typo because I solved it, but it ends up with way too many complex fractions, improper fractions that don't show up in the textbook, and we haven't really had anything in the homework or worksheets or anything that comes up. So I'm just telling you to skip this one. Okay, I'll go over it in class if you'd like, but for now we'll skip it. So number 8 is a candidate for synthetic division because we're dividing by a plus 5, which is, a minus 5, a plus a negative 5, or a minus a negative 5, right? So the number that we put here is negative 5. Okay? And these are the coefficients of the polynomial of the dividend, the one we're dividing, in standard form. So I had to rearrange the terms so that this is the 5a to the third, this is a 3a squared, this is the negative 3a, and this is a constant. So now I'm going to continue with synthetic division. So let's bring down the 5. 5 times negative 5, negative 25. You add these two, you get negative 22. And then you multiply, you get, by negative 5, you get 110. You combine, you get 107. And then when you multiply, you get negative 535. Okay, and then when you combine, you get negative 540. Okay, so negative 540. So now the dividend would be 5. They're using a 5a to the third minus 22a squared plus 10. Oops, I'm taking the wrong. I started off the right way, but then I started using the coefficients. So 5a to the third plus 3a squared minus 3a minus 5 equals the divisor, a plus 5, times a quotient, 5a squared minus 22a plus 107 plus the remainder. So in this case it's negative 540. Now I can just put minus 540 without the plus and the parentheses with a negative 540. Either way is fine. So here's the final answer. Okay, so for number 11, we are going to add and then write it in standard form, give the degree, the number of terms, and the leading coefficient. Okay, so I start off by looking for the highest degree. In this problem, it's this one, and there's nothing to combine it with. So then I just bring down 7x to the fifth. Oops, to the fifth. And then the next one down is x to the fourth. So again, this is the only x to the fourth right here. So I'm just going to write it down minus 10x to the fourth. And then x to the third, there's no x to the third, but there are two x squares, this one and this one. So combined, that gives you negative 19x squared. There is no x, but there are two constants, the 16 and the 5, and so that gives you 21. Okay, so this is considered a polynomial because it has 4 terms. It doesn't have a special name, so it's just a polynomial, a degree 5 polynomial, and the leading coefficient is 7. So the degree for this one is 5, the terms is 4, and the leading coefficient is 7. So for this one, let's go ahead and change the signs because this is subtraction. So we're adding the opposite. So we can just make this, we're adding the opposite. So that's a minus, that's a plus, this is a minus, and this is a minus. Okay? And so now we're ready to combine like terms. So the highest degree here is this one. So we just, and there's no other 18th power, so we just bring it down, 57x to the 18. Then the next power down to that one is 3. So there's this one and a C only 1. So we just write it down, plus 71x cubed. There are two x squares, this one and this one. So negative 5x squared and negative x squared is negative 6x squared. And then there is 1x, negative 6x, and one constant, minus 2. So 2, 4, 5, this is a polynomial, an 18th degree polynomial. So the degree is 18. The number of terms is 2, 4, 5. And the leading coefficient is 57. Okay, so this is another addition problem, so we're going to go through and look for the highest degree, and that would be a square, x squared, so there are two of them. So 21 minus 3 is 18. There are two x's, this one and this one, so 8 and 1 is 9. And then there are two constants, 1 and negative 1. That cancels out, so then you're left with this one. So the degree of this one is let me just change it here. The degree of this one is 2, the terms 2, and the leading coefficient is 18. So you can call this a square binomial. Square because of the degree, and binomial because it's only two terms. So for number 14, we're subtracting, so that means that we're adding the opposite. So we're adding the opposite, like that. And the highest degree here is x to the fifth, and there's only one. Next one down would be to the fourth power, there's only one. There's no third power, there's a squared second power, so that'd be negative 13x, and there's only one. And then after that would be constants. There's a negative 9 and a negative 11, so that gives me negative 20. Okay, so this one, the degree is 5. The terms are 4, so it's a polynomial. And the leading coefficient is 3. Okay, so for 15 I set up a 2x3 grid, and notice I just kept the same order as the original problem. When I write my answer, I'm going to write it in standard form though. Okay, but for now it doesn't really matter, we're just setting it up the same way that it was given to us. So you multiply, right? 3 times 4, 3 times negative 7x, 3 times 5x squared, 2x times 4, 2x times negative 7x, and 2x times 5x squared. Okay, so the highest degree here is 10x, the third power, so it's going to be 10x cubed for my first term. Then second degree would be this one and this one, so a quadratic one. 15 minus 14 is positive 1, so that's plus x squared. And then x's, there are two of them, this one and this one. So negative 21 plus 8, that gives you negative 13, and then the constant 12. So this is a degree 3, so it's a cubic. 4 terms, so it's a cubic polynomial with leading coefficient 10. So 16 is similar to 15. I set up a 2x3 grid. So you multiply across, and then negative 3x squared, and then negative 4x squared, negative 10x, and then 6. So the highest degree here is 4, so we're going to write, and there's only one of them right inside the grid, so you're going to write 2x to the 4th. Then x cubed, there is only one x cubed, so you bring it down, 5x cubed. Squared, there are two of them, negative 3x squared and negative 4x squared, so you can combine those two into negative 7x squared. There's only one x, and there's only one constant. So this is a 4th degree, so quartic polynomial, because there's 1, 2, 3, 4, 5 terms. So the degree is 4, the number of terms is 5, and the leading coefficient is 4. So this is a quartic polynomial.